Hello, in this video we're going to be finding error intervals. So the objective here is to understand how rounding creates an interval of possible values and to write this interval using inequalities. So when a number is rounded, it is not exact, it lies within a range. So for example, if x is 30 centimetres to the nearest 10, there's a range of values that x could have been before it was rounded to the nearest 10. So here's a definition. The error interval is the range of values that would round to the stated value. So the lower bound is the rounded value minus half of the rounding unit, and the upper bound is the rounded value plus half of the rounding unit. So the lower bound is the smallest value that the number could have been before it was rounded, and the upper bound is the largest value that the number could have been before it was rounded. So here's an example. X is equal to 8 centimetres to the nearest centimetre. So if we draw this out on a number line and mark in 8 centimetres. So if we say to the nearest centimetre, I know 8 centimetres is between 7 centimetres and 9 centimetres. So the values that are closer to 7 would round down to 7, and the values that are closer to 9 would round up to 9. However, the values that are closer to 8 would round down to 8, and the values between here that are close to 8 would round up to 8. So the aim of the game here is to find the range of possible values that would either round up to 8 or down to 8. So to do that, we find the midpoint between each set of values. So for this one, between 7 and 8, it's 7.5, and between 8 and 9, it's 8.5. So therefore, all values that are 7.5 or more would round up to 8, and all values that are 8.5 or less would round down to 8. However, 8.5 itself would round up to 9, so that tells us that it can't be equal to 8.5, but it can be anything up to but not including 8.5. So the way we write the inequality is we say 7.5 is less than or equal to x, which is less than 8.5. So this tells us x cannot be equal to 8.5 because 8.5 would round up to 9, but it can be anything up to but not including 8.5, and it has to be 7.5 or more. So this one here, we have 4.2 metres to one decimal place. So again, if we draw a number line, we have 4.2 metres and it's to one decimal place. So we're going to put the decimal places between 4.2. So that's going to be 4.3 and 4.1. So to find the error interval, we find the midpoint between the two. So this one is going to be 4.15 and this one is going to be 4.25. So this tells us any values that are less than 4.25 are going to round down to 4.2, and any values more than 4.15 are going to round up to 4.2. So the way we write the error interval is we say 4.15 is less than or equal to y, which is less than 4.25. It can't be equal to 4.25 because 4.25 would round up to 4.3. Here's another example. So this time we have 3,450 to the nearest 10. So I'm going to write down 3,450. And to the nearest 10, I'm going to write down the other two values, which is 3,440 and 3,460. So again, I'm going to find the midpoint between the two. So the middle number between 3,440 and 3,450 is going to be 3,445. And then the other one is going to be 3,455. So the error interval is going to be 3,445 is less than or equal to p, which is less than 3,455. So this one here, 7 kilograms is to the nearest kilogram. So on a number line, we'd have 7 kilograms here and to the nearest kilogram. So I'm going to put the 2 kilograms either side. So it's 6 kilograms and 8 kilograms. So in the middle of 6 and 7 is 6.5, and in the middle of 7 and 8, that's 7.5. So we're going to have 6.5 is less than or equal to m, which is less than 7.5. This one here, we have 2.38 seconds to two decimal places. So I'm going to write the number, so 2.38, so to two decimal places, that's going to be between 2.37 and 2.39. So the numbers in the middle of these is going to be 2.375 and 2.385. So it's going to be 2.375 is less than or equal to t, which is less than 2.385. This one here, so 4,600 is measured to the nearest 100. So on a number line, to the nearest 100, we have 4,600, and that's between 4,500 and 4,700. So the midpoints between the two is going to be 4,550 and 4,650. So that means we have 4,550 is less than or equal to D, which is less than 4,650. This one, 72 is measured to two significant figures. So to two significant figures, we have 72, and then the two significant figure numbers either side are going to be 71 and 73. So the middle of 71 and 72 is 71.5, and the middle of 72 and 73 is 72.5. So this one's going to be 71.5 is less than or equal to X, and that is less than 72.5. So here are some quickfire practice questions on this topic. Pause the video, have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. I've just revealed the answers on the screen, and that's everything for this video. So thank you so much for watching, and I'll see you again in another video. Bye!